Good morning students. Hello, can you hear me?
Morning, sir.
All right, good. So let's get cracking, guys. No hesitation. Session is being recorded, so persons who are not here yet can watch the video to catch a start. So I want to start with this that is on the screen, which is a class activity that we did in the last class. We're still on the functions topic, and we're also doing variations. And this is the last day that we're doing this topic. Next time we're doing this topic is in revision. Moving on to a new topic tomorrow, which is coordinate geometry. All right, so let's go. So these questions are set up to test certain specific areas of the functions topic, and they are mainly the areas that don't come on every question, right? So we did the session that we did last week, what we covered last week, were the areas of functions that you see almost on every exam question, all right? But you're primarily required to know about functions. But today, this week we did the areas that don't come very often. And the first question here is about how do you use the inverse function to solve an equation? That's what this is about. Easy. So I'll give you this very easy function, very easy example, an easy function. And the first part is saying we have to find f to the minus 1, which is the inverse. And then it says hence. So the word hence here means that we must use this to solve this equation. Now that's a simple linear equation. Somebody in prep school can solve that, right? So I don't expect it to go about solving that. This question is specifically testing if you know how to use the inverse function to solve it. So it's a very simple function, but then it is a method, it's the approach that is used. So somebody who solved this in the normal way, 3x minus 4 equals 5, and transpose the 4 over there and get 3x equals 9, and then divide by the 3 and get x equals 3. You might not get any mark for doing that, because you would not have used the inverse function. Alright, so this question is specifically testing your knowledge of using the inverse function to solve an equation. But let's go through the question though. Let's find the inverse first. So this is the function over here, f of x. I'm going to say f, let's call it f as we always do. F equals 3x minus 4. And then we're going to inverse this function. We're going to form the inverse. Alright, we're going to form the inverse. And this f on the function is range, it becomes domain on the inverse, which is x. And this x on the function is domain, it becomes range on the inverse, which is f to the minus 1. So everything goes back. 3, and then as I said, the x becomes range, which is f to the minus 1. And we're subtracting this 4. And so we have formed the inverse function. It's just that we need to make this f to the minus 1 a subject. So how do we do that? We can transpose everything away from it to that side. First thing to move is this negative 4. When negative 4 comes on this side, it becomes a positive 4. So we have x plus 4. And then that now will be equal to this thing. Right? That will be equal to that thing. But what we want to get rid of the 3. So we're going to take the 3 and divide it on this side. Same as saying you divide both sides by the 3. But we must know the shortcut now. So we divide this 3 under here. And that leaves this f to the minus 1 as a subject. And then now that we're finished, we can put in back of x. So then we can write f to the minus 1 of x is actually equal to this thing. X plus 4 over 3. Alright, and then we'll come to this part now, which is to hence solve this, right? So we're doing hence solve 3x minus 4 equals 5. Now this hence means that we have to use this inverse to solve this equation. Alright, so this is set on the premise of us knowing how an inverse function can be used to solve an equation. Let me remind you. For any one-to-one function, if f of x is equal to some value, You're trying to find the x. And the x that you're trying to find is f to the minus 1 of that number. The number over here. Simple as that. That's what we're using. Alright, so how do we get to use this? Let me move this out of the way. It is to recognize, hold on. It is to recognize that this thing right here is actually f of x. The f of x that we're given over here. 3x minus 4 is f of x. So what we really have down here then is that f of x is equal to 5. It's simple. F of x equals to 5 means that x is mapped onto 5 with this function f. This is x you want, you know. So it means that the 5 is going to map back to the 4, to the x, sorry, with f to the minus 1. Alright, that's what it means. Alright, so write it like this. If f of x is equal to 5, then the x becomes equal to f minus 1. Mute your mic, please. Mute your mic.
Okay.
Alright, and so that's how we're going to be using the inverse function right here by plugging the 5 in that function. And so the x that we want in this equation is equal to f to the minus 1 of 5, which is the put 5 here. It becomes 5 plus 4 over 3. And that works out to the same 3 because that's 9 over 3. And basically that is it. Hello? I'm in class now. Alright, so about that, guys. So that is the answer for that part. Simple as that. So that's what they wanted. So we did not want to see you solve this straight. We didn't want to, you're not getting that to solve on the exam at CSEC level straight. That's too easy. Alright, so that's the first question that we did. Alright, so the second question was testing our knowledge of what makes a function, a rational function, undefined. It's quite simple. The function is undefined. This rational function becomes undefined, not real. It cannot work when the expression in the denominator is equal to 0, because we cannot divide by 0. So any value of x that will make the denominator 0 cannot be in the domain of this h function. Cannot accept that value. So that's what the question is. What value of x will make this function undefined? What value of x we cannot use on the function? That's what we're calculating, you know. So we simply put the denominator equals 0. So h of x is not defined when the 2x minus 3 becomes equal to 0. When this becomes equal to 0. And it's solving for the x out of this. Transpose the 3, you get 2x equals 3, and divide under the 2. You get x equals 3 over 2. So if x equals 3 over 2, the function is undefined. So it means that this 3 over 2, this x equals 3 over 2 cannot be in the domain. Cannot be in the domain of h of x, because it has no value mapping onto, because the function with this value of x will become some number over 0. That's what this will work out to. Some number over 0, which cannot be worked out, is an undefined quantity. Alright, and so the 3 over 2 in domain would not have any value mapping onto. If you have any value in the domain that is not mapping, if you have any value in the domain that is not mapping, it means that that relation, that mapping is not one for a function. Alright, and so this would not be a function anymore if there's a value in the domain that's not mapping. And that's the answer for that one. Right, the value of x that to make that function undefined is 3 over 2. So 3 over 2 cannot be in the domain of that function. Done. Alright, then we'll come to question 3. Right, so this was a very easy classwork. You do a lot of it, took a lot of time to do it. It was very easy, but no problem. Progress before perfection. Alright, progress before perfection. Eventually we'll be able to work these questions quickly. Alright, so this question gives us this composite function, another thing that they don't set often. Where they give you a composite function, you have to break it into two simple functions. Alright, so again, they don't set this very often. So I want you to be exposed to all the things that they don't set often in CSEC. Alright, so it's f of g of x is equal to 3 into 2x minus 1 plus 2. And there's a two-steps method to this thing. First step is that we're going to find this inner function first. I'm going to let it be equal to the expression within, which is right here. That is the first step. Because remember, when we're forming a composite function, it is the inner function, this one, that moves. Technically, it's the inner one that moves. You can look at it that way. So this is gonna be equal to that. Alright, then what's gonna happen next now is that when this comes out, we're gonna replace that value with an x. And then what we have left will be the outer function. Simple as that. So the g of x becomes equal to the expression within. So that's the first thing. Let the g of x be equal to 2x minus 1. Then we will take out the g of x, you're putting back x in its place because you're doing the reverse of how we form a composite function. So we can say, therefore, the f of x is going to be equal to, when this x goes in that place, you're going to get 3 times this x that's going back in plus this 2. That is it. And remember now, when you get these two functions now, right? If you're not sure, you can think of it, if I were to reform that composite, f of g of x, it would have meant g into f. It would mean all of this g coming into the f where x is right there. And you would have gotten back this expression. And that's how you can know that these two simple functions are correct. By testing to see if you would get back the same composite that you split. And that is it. It's the first part. Alright? That finishes part A to find those two simple functions. Then part B says find g to the minus 1 and find f to the minus 1. And then here now it says hence. Again, the hence means that we must use these two things to find this. So this now is testing your knowledge of inverse of a composite function, which is something again that they don't say it often. Alright, inverse of a composite function. So using these same two functions over here, using the same two functions over here. So firstly, they want g to the minus 1. So I want to start with this g and say that g equals 2x minus 1. This is part B we're doing now, you know. And I'm going to inverse this. The g becomes x equals, and this x becomes g to the minus 1. Alright, this is better. 2 times g to the minus 1. So this domain becomes range on inverse function. So put minus 1 on it. Minus 1. We're trying to make this a subject. How would we do that? Transpose everything away from it. Move this 1 over here first and get x plus 1. And then take this 2 that is multiplying and divide it on here. And that leaves us with g to the minus 1. So g to the minus 1 of x is this. So we can write it. G to the minus 1 is equal to x plus 1 over 2. That is g to the minus 1 of x. Now we need to do the f now. Let's do it beside it. F. So what this inverse of this? We want to say f equals 3x plus 2. Inverse this. This f which is range become domain equals 3 times this x which is domain becomes range on the inverse function, which is f to the minus 1 plus 2. I want to make this a subject, same thing. Take this 2 and bring it over here first. We're going to get x minus 2. Then take this 3 and divide it under. And that now is f to the minus 1. we can write f to the minus 1 of x actually equal to x minus 2 over 3. So finish the first part of finding these two inverse functions, and it says now hence find this. So what does that mean? Let's put it here in a different color. It says hence we're finding fg all to the minus 1. That's what we want to write here, fg all to the minus 1. What it is that we must know that fg all to the minus 1 can be in terms of these two inverse functions. What is it? Or is it written in terms of those two? Because it is actually equal to the composite of the two inverses. Just like the composite of g comes in front, right? The composite of the inverse goes in front, so it becomes g to the minus 1, and this goes second. So since it is front and this side, it goes second over here, f to the minus 1. And that's how we form this, by knowing that this is actually equal to that. So you cannot do this unless you know that information, right? Inverse of a composite function. And we'll basically working this out in the normal way of how we form a composite, which is to put this one into this one. So putting the f1 into the g1, so it means that all of this f1 is going to come into the g, right, there where x is. That's how we form that composite function. Right, let's go. So it's gonna become equal to, back to the purple, Mr. Shaw. So where this x is, we're gonna put all of the f there, f to the minus 1. So we're gonna get x minus 2 over 3 plus back this one, side it all over 2 under here. That's the answer I'm looking for. Now this can be simplified, right? Because to get rid of this 3 on the numerator, in the fraction on the numerator, we could multiply the numerator by 3. We would have to also multiply the denominator by 3. And then what would happen? This is also simplified. What would happen is that the 3 times this fraction would cancel the 3. And we would have x minus 2 left. And then the 3 times this one is 3. 3. And we're dividing that by this 3 times 2 right here, 2 times 3, which is 6. Then this one will give me plus 1, that's 3 minus 2 is 1. So x plus 1 over 6. That is the answer for that. But alright?
Yes, sir.
I'm saying all this already, right? You really want to see how questions that are sent are done. So those of you who did them, yeah, you want to see the mistakes. That finishes that question. The next question is a variations question, number 4, down here. Alright? Remember, the variation that you're doing can either be direct or inverse. If it is direct, remember it's k times, like to be k times x squared. Like for example, you'd have y equals k times x. If it's direct. If it's inverse, it will be something like y equals k over x. And we're always trying to find the k first, alright? That is the key thing about direct variation and inverse variation. Which one do we have? Alright, let's look at this question. This question says, given that y, so the first variable is a y right there, varies directly. So it's a direct variation. So it's directly, that's a keyword, as the square of x. Square of x is with the x squared. That's what the square of x is, x squared. Alright, so those are the two variables, and it's a direct variation. But that sentence alone simply means that the y is equal to k, constant of integration, variation constant, sorry, times x squared. That's the first thing, because direct, it says. Directly, varies directly as square of x, which is x squared. So this is what you're working with. And the method we're using in this class, we're trying to find the k first, so we can know the formula fully. The k is a constant. For you to find this k, they have to give you a known pair of values, either in the wording of the question or in this case in the table. And in this table, it is obvious that the
Lord,
mean pair is this.
you are awesome.
This is
Guess
for
what?
the
That's what
key.
I have to find
So
something
that is
to
for
correct
you to find the key,
right.
right? That is what that is for you to find the key. That's a real reason for this. All right. Now remember, the question can be done without finding a key, but we are practicing a method. We'll find key first, especially because some questions will actually ask you for the key. The variation is constant. All right. So we're gonna use that pair of values x, y value to find the key in this formula. You're putting them in this formula. So let me go. Let's find key first. So find key first. Now when you know key, then you want to know the formula fully. Alright, connecting the x and the y. And use this pair to find the key, this pair of known values. X equals 2 and y equals 8 to find the value key. So you plug these two values in this formula, you plug the 2 right there and the y 8 right there. Plug them in there. Alright, so we're gonna get that the y is 8, so we're gonna put on the 8 is equal to k and then x squared times x squared, which is 2 squared, because x is 2. This right here says a 4. You can divide the 4 under here, and 8 over 4 is 2. Or you can look at it and say, this is the 4. What do I multiply 4 by to get 8? 2. 4 2 is 8. Anyway, you want to look at it, the k is equal to 2. Now that the k is equal to 2, you're going to take it now and put it in the formula here. So let's continue. So we're going to use this and this to now write the formula. Right? Let's put it here, which is the y equals 2 times x squared, because the k is 2. Right? So this formula governs everything you do going forward. That's how you connect x and y now numerically, the actual values in this relationship. Alright, so the first thing here is that I want us to find the value p, and when the value p is a y value when the x value is negative 1. So I want to plug these pairs, this pair of values now, into this formula over here. Alright, to find out what the p is. So let's write it. So the first thing, let's do it in black, a different color, or purple. First thing is that x equals negative 1, y equals p. You plug these values in this formula. So the y is p, so we can say therefore the p is equal to this 2, and then the x that you're squaring is negative 1 times minus 1 squared. Alright, so the p equals 2, and this becomes a 1, and so p equals 2. Easy like that. And then the other pair now is over here, the q and the 18. So I'm going to use the same formula over here and say when the x equals q, y equals 18. Plug them in the formula. So therefore 18 is equal to 2 times this x value is q squared. I want to make this q the subject. First we're going to divide by this 2 and get 18 over 2 equals q squared. 18 over 2 is 9. So 9 equals q squared. Alright, so it's a direct variation. So you want to know, because remember now, when you calculate the q from this by square root in both sides, so we're going to square root this side and square this side, so that the square root we cancel away the square and leave us with a q. Right? But when you do that, it can be plus or minus. So the table now, if we decide whether to use the plus or the minus, right? So if you look at the table, remember it's a direct variation now. So when these values increasing, these values also increasing. Alright? So it means then that the value for q has to be a value greater than 2. So we square root this using the positive square root over here, this one. So the q then is going to be the square root of 9. Q is going to be equal to 3. And the question done. But okay with that?
Yes, sir.
Alright, beautiful. Beautiful. So we took a few minutes to do that. Alright, let's do some past paper questions now that I sent you guys. Let's see. Let me see what the first one was that I sent you. Don't have them written down here. Let me see. Let me see. Alright. I think the first one I sent you was 2017, January 2017. Let's find it over here. January 2017. And some of the papers I sent you, they have some variations. And also, where is it? Not here. Let's see if we can find it. Let's see. Alright, there you go. What question did I tell you to do on this paper? I told you to do. Where is it? Oh man, where is it?
4-8.
I think 4A, thanks. 4A. Let's find it. You can just remind me because I don't have the thing looking at. I have to be searching for it. 4A. Oh, so that's straight functions, Christian. Simple one. So I don't have any sugar on it. It's a straightforward one, so this should be good. Alright, there's nothing to it really. I went back too far. Back too far a while ago. Alright, there you go. Nice and easy. Nice, easy functions. I'll give us these two functions, f and g. And the first part one is g of 0 plus g of 5. So I'm going to put the 0 in there and also put the 5 in there. So the g of 0 is when you put the 0 in there in the g function. So it will be 3 times 0 plus 1 over 2 plus this plus now. I'm doing g of 5 over here. So g of 5 now is when you put 5 in there. So it's going to be 3 times 5 plus 1 over 2. Simple as that. So this works out to be what? This works out to be a 1 over 2. This becomes 15 and 1, 16 over 2. When you add them up together, because it's the same denominator, it becomes equal to 17 over 2. And that is the answer for that one. G of 0 plus G of 5. Alright, nice and easy. Everybody good with that?
Yes, Yes, sir. sir.
Alright. Next part wants f of g of 5. So we can do this step by step. Remember that f of g of 5 means that we're doing the g of 5 first. So this is same as f of g of 5. Right, the thing is that we actually did g of 5 up here. This is g of 5, you know. And g of 5 based on this is equal to 16 over 2, which is 8. Okay, make a note. Alright, that g of 5 is actually equal to 16 over 8. 16 over 2, which is 8. Right? So we can put back this 8 inside here, because that's what g of 5 is. So this simply becomes, we have to calculate it again. This simply becomes f of 8 now. And so f of 8 now means that we'll put in 8 in this f function up here. Alright, and so this becomes equal to 4 times 8 minus 7. 4 times 8, ouch, minus 7. Alright, so that becomes 4 8, so 32. 32 minus 7 is what? 35? No, 25? Who did it? Anybody? That's correct.
Yes, sir.
Alright, good. Next one. Once f to the minus 1 of 1. I'm going to show you now. I'm going to show you, start to show you now another way that you can find f to the minus 1 of a value without actually finding the inverse function first. Alright? You have to evolve and grow. Alright? I'm going to show you another way. So I'm going to do it the two ways now. I'm going to show you the other way first to do this. Alright? Watch carefully now. So, let me write about f of x is first. F of x, remember, is 4x minus 7 is equal to 4x minus 7. And we are asked to find f to the minus 1 of 1. Not f to minus, not f of 1 and f to the minus 1 of 1. Look at this method now. You can say, okay, you want to find f to the minus 1 of 1, let it be equal to n, some number n. Now, if f to the minus 1 of 1 is equal to n, what this means is that 1 is mapped onto n using f to the minus 1. So it means that the n is mapped back onto the 1 using the f, the inverse function. And you can see it even in this. If f to the minus 1 of 1 is equal to n, then this 1 is like you transpose the f to the minus 1 and make it f. Right? So the 1 becomes f of n. You're trying to find n in it. So when you find the value of n, you basically have the answer, right? Because you're calling this thing n. So whenever you find this value of n, you have the answer. So what is going to happen is that the 1 inside here is actually going to be equal to f of n. So what is f of n? F of n is just plugging the n in this. So this then becomes that 1 is equal to 4 times n. Okay, plug the n in here now. Minus 7. And so, simple solving this simple equation for the n. Trying to find the n. How do you do that? You're going to carry over the 7 first and get 1 plus 7 equals the 4n. And you can take this one and divide it under here. So I'm going to move it one time. Let's put the hold on. Right, so we can take this 4 and divide it under here, so it will be gone. So let me take it out and show you. Alright, they put the 4 over here. Under there. And so you're gonna get the n equal, that is 8 divided by 4, which is 2. So the n is 2. Means that this therefore is equal to 2, because this is 2. So f to the minus 1 of 1 is equal to 2. So you can write therefore f to the minus 1 of 1 is actually equal to this n value, which is 2. So the answer is 2. That's one way to do it. Alright, the other way to do it is to find f to the minus 1 first. So, or using another method. What we're going to do, find f to the minus 1 of x first. Then put 1 in there and put f to the minus 1 of 1. Alright? Let's do it that way. Let's practice. So we're going to inverse this function first. So you have f equals 4x minus 7. So you realize that whether you do it this method or you do it this method, you have to transpose to make whatever is in this position the subject. So over here, we transpose to make this thing the subject. So anyway you take it, the thing in this position has to be transposed into the subject. Alright? So we'll form the inverse function. Okay? We're trying to find f to the minus 1 first. This f becomes x equals 4 times. This x becomes f to the minus 1 minus 7. So you see the thing in this position, we're trying to make it the subject. So again, we're going to take this 7, bring it over here. It's going to become x plus 7. And you take the 4 and divide under there. That's over 4. And then you have f to the minus 1 left. And that's really f to the minus 1 of x. You can put in the of x. And so if you want to find f to the minus 1 of 1 now, you just put the 1 in there. Put the 1 in there. Right? I have a mistake. This should be 7. this right here actually should be 7. When this negative 7 comes over, it becomes a positive 7. So this is 7 right here. Good. So we're going to put the 1 in there and put the 1 in there as well. Alright. So then we can conclude and say, therefore, f to the minus 1 of 1 equals, put the 1 here, you get 1 plus 7 over 4, which is the same thing we have right here. So you get the same answer, equals 2. Very good?
Yes, sir.
So going forward, you know,
Yes, sir.
forward,
Yes, sir.
before I'm going to be doing them, some of them this way, right? So I think everybody understands this way. So the question don't ask for the inverse function, but it asks for if the minus one have value, you can actually do it this way. Like I just did. Call it n, and then make the figure in here equal f of n. Set up this equation with f of n equals the value, and then solve for the n. When you find the n, you're done. Alright? So we want to be able to do some of them this way. Some of them will do this way, but sometimes we do them this way. Alright. I think that finishes that question. Was there another question on this paper for you to do? Was there variations on this for you to do? I think so. Was there variations on the first paper that I gave you? Somebody remind me. I'm not able to look at it, guys. Remind me. Nobody answering. Yes, I do 9A. 9A. 9 is a variations. Yes, it is. There it is. So I gave you this one to do as well. That's a variations question. This one says, table below shows pairs of values of x and y, where y is inversely proportional to x. So inversely means q over, and the two variables are simply y and x. First part is telling you, express y in terms of x and a constant k. That's a formula I wanted to write, you know. So y is equal to k over x, because it's inversely, that's it. That's what I want to know. The next part now is calculate the constant k. So to calculate the constant k, we can take this x and multiply it up here. It's convenient when it's an inverse function we have. So we can have xy equals the k. So you see the question, this question asking for k. The ones that we did before did not ask for k. So that's what we're going to see with these questions. So to find this k using a known pair of values, you can use this pair or this pair. Doesn't matter. Any one of the pairs you can use. The known pair of values. This one I'm to give you 2 pairs. Right? The result will be the same, whichever one you decide to use. So let's say we're using the x equals 3 and the y equals 2. You plug them inside there. So you're going to get 3 times the 2 equals the k. So 3 times 2 is 6. So the k is equal to 6. If you use the other pair, you're going to get the same answer. Right? So you have the xy equals k, just the same. It's our method now. Right? And you're using the x equals 4. X equals this 4 up here. And the y equals 1.5. And you plug them inside here. You're going to get that 4 times 1.5 is equal to k, which again means that k, 4 times 1.5 is 6. K equals 6. Alright, that's answering the first part. The next part now says, find the value of A and value of B. So what it is now, you're going back to the original method. Since you know what the k is, you can plug it in this formula right here. So you know that xy is always equal to 6. So the formula becomes xy equals 6. Because the k is 6. That now is your known formula. Alright? So to find the a, we're coming on this pair. X equals a, y equals 1.2. Alright, so we're doing it here first. X equals a, y equals 1.2. I'm plugging these two values in this formula. It then means that a times 1.2, so the a is the x, 1.2 is the y. That's equal to the 6 over here. So the a then becomes 6 over 1.2 That looks like a 5. That's 5. That looks like a 5 to me. Yes, it is a 5. So A equals 5. And then this one now, we're going to use the other pair on this one, and the formula again. So up here now, trying to find the B on this pair. That's x equals 20 and y equals b. I put them in the formula. X equals 20, y equals b. X equals 20 and y equals b. So you plug them again in this formula. So you're going to get, therefore, 20, that's the x, and the y is b. So it's 20b equals 6. Right? Equals this 6 over here. And then now you want to find the b, you take this 20 and divide it under. Right? So the b equals 6 over 20, which is 3 over 10, which is 0 0.3. So the b is 0 0.3. I'm giving them back decimal because they gave us decimals. I can give them back this as a decimal. That is stand on. I don't usually ask anything else after that. But okay.
Yes, sir.
Yes, sir.
Alright, we're getting everything right, you know. Anything you get wrong, go and redo it. Don't joke. Alright, next paper I gave you was 2022. 2022. Let's see if I have it up here. This one. And you have to do number 4A and number 9A. That's it? No. 2C and 4A. I see a 4A here on the screen already. But let's go back to 2C first. I think 2C is a variations question. Alright, 2C. Good. And see that's a worded variations question. No table. Alright, let's look at this one. Work it down. It says the height h of an object is directly, meaning k times. So the first variable is h is equal to, directly means k times the square root of its perimeter. The height of an object is directly proportional to the square root of its perimeter p. That's the square root of p. That's it. That's the relationship right here. That is it. The height h of an object is directly, meaning k times, directly proportional to the square root, not square, not square root of its perimeter p. Write an equation to show this relation. Alright, that is it. See here? This is it. This is it. That's what I want. That's it. I can tell them k is a constant. K equals constant if you want. Variations constant. Then it says, given that h equals 5.2 and p equals 1.4, determine the value of h when p equals 2.89. So this now is to find a k. This is for the k. But as I said, you don't need to find the k, you know. Alright, this one didn't ask for the k. You can actually do the question without finding the k. But we're gonna let us master finding the k approach first. And over here now they want to know what the h is when the p is 2.89. Alright, let's go. So what we're gonna do is plug this pair into the formula up here to find the k. Alright, so we're gonna use that to find k first. These values go in here and here. So you're gonna get the y is 5.4. So you're gonna get 5.4 is equal to k times square root of 1.44 square root of 1.44. So if you want to find the k, I'm going to divide by this. So the k equals 5.4 divided by the square root of 1.44. Now we have to log off the calculator and get the k equals what? Let's see. Get the calculator. Where are you, calculator? Here you are. 1.44, that's what, 0.12. No, 1.2. Let's see, alright, so it's 5.4 fraction. 5.4 over square root of 1.44. 4.5, so the key is 4.5. 4.5. Well, that the key is 4.5. You can plug that 4.5 value in the formula right here. Right? So we now know that we can say therefore the h is actually 4.5 times the square root of p. Let's go back up here now. We now know the h, the k, so we'll just plug it in the formula and we'll get this. And the question wants the value of h when p is that value. So we're going to say when the p becomes 2.89, the h becomes this thing, 2.89 is this, and that. So we'll get 4.5 times the square root of 2.89. And then we can work that out again with the calculator. It's 4.5 times the square root of 2.89. So get h is 7.65. That's the value of h. That's the value of h, guys. Very good?
Sir.
Remember, guys, if you didn't get it, go and do it over by yourself. It's not difficult. You have to practice. Alright, I gave you number 9 on this question, on this paper as well. Number 9 is functions. Let's see. So you said that on the past papers, you can do them on the past papers. 9. Hold on a minute. There's only one question I gave on this paper is 2. Pass it. Oh, 2C and 4A, my mistake. 2C and 4A. 2C and 4A. Here you go, 4A right here. Alright, that's an easy question, this one. Quick and fast. This question says, it gives us these two functions, f and g, and it wants g of a third, so you plug this into the g1. A lot of people made mistake I put in the first one that I see now, but you have to pay attention to the details. It's g on, so going on that function. So this becomes simply equal to 3 times, so plug in this 1/3 right there, where the x is a third minus 1. Now 3 times a third is 1. This cancels this. And you subtract by this one. So the answer is 0. Alright, easy, standard question. Again, we're going to practice this now. I want f to the minus 1 of -3. Let's do it again this way. We'll find the f to the minus 1 of x first. Let's call it n. And therefore, the -3 is equal to f of n. That's the method we're using. What is f of x again? F of x is, what is it? 5x plus 7 up here. 5x plus 7. So to find f of n, I'm going to plug the n in this. So I get minus 3 equals 5n plus 7. We'll solve this and we have the answer. So I take this 7, bring it over here and subtract it, right? So you're going to get minus 3 minus 7. Take this 5 that is multiplied and divide it on here. So divide the 5 on here, left with the n. So this works out to be -10 over 2. which is negative 2 is equal to n. So you can write that n is equal to negative 2 somewhere down there. But not the n, the inverse function, my mistake. Right? Because the n comes out to that. So you can say therefore f to the minus 1 of negative 3 is equal to negative 2. That's good enough, guys. But alright with that?
Yes, sir. Yes, sir.
Yes, sir.
Practice this sticker method, alright? It's not fast. You have to look at the inverse function first. Let's do it this way. Alright, let's go. That finishes that question. Feel like it's gonna be a quick session, you know. Finish quick today, kind of that's good. I like when the sessions are short, spicy. Alright, 2023 is the next paper I gave you. Question 8A only, I think. On that paper. Let me see. Let's see this thing. 2023. Right here. There you go. Question 8A. Alright. I'm going to with this question. It asks us a g of x minus 2. It asks us a g of a value as a number, but it don't matter. Put the x minus 2 in the g function here, same way, and work it out. Right? Simple as that. So these are the three functions presented: f, g, and h, and I want g of x minus 2. So g of x minus 2 means that I want to put x minus 2 in the g function right here. So then will become x minus 2 squared minus 5. Expand it and subtract 5 equals, expand the x, you're gonna get x squared, then twice the product of the 2. Remember, when you expand a perfect square, you're gonna get twice the product of the 2. So that is minus 4x. And the second term squared is a plus 4. And then you have to subtract this 5 out here. So it becomes x squared minus 4x minus 1. That is it. But alright with that?
Yes, sir.
But,
Yes,
yeah?
sir.
But it go? Alright. Next part was f to the minus 1 for 11. Same thing again. Let's call it n. So the 11 is equal to f of n. What is f of n? F of n is this. F of x, sorry, is that 4x minus 1. So f of n is 4n minus 1 equals 11. So n equals 3. Take over this and add it to get 12 equals 4n. Divide by the 4, get n over 4, not n, 12 over 4 equals n. And so the n equals 3. 12 over 4 is 3. And therefore, f to the minus 1 after 11 is equal to 3. Down here now, this one's h of 1 could have been same as h squared of 1. Since I've said h of h, I could have said h squared. And what is the h function again? The h function up here is 3 to the x. Alright, so h of x is 3 to the x. So we're doing this one first. So h of 1 is what this becomes. It becomes h of, I'm putting 1 in this. So it becomes 3 to the power 1, which is equal to h of 3. And h of 3 now, I'm going to put 3 up here again for the x. So that becomes 3 cubed. So I put this x up here for the x. 3 cubed. And then that becomes 27. Anything else on this question? Nope. That's it. That's it. Nice and easy. I think this was the only question on this paper I gave it to you. Don't think there was any variation on this paper. But alright? But good?
Yes,
Yes,
sir. Yes,
sir.
sir. Yes, sir.
Well, you're really getting an early day today, guys, which is alright. So we have two more papers I gave you. I gave you 2021. So you see, these are all recent exam papers, guys. So, and you can do them in here, in the classroom. You can do them in the practice. When exam time comes, you can do them as well. You don't have to be fearful of these things. See what we're covering in class, what we're doing in class, is what's coming on the exam papers. So, you know, you're preparing the right kind of material. Have to prepare for the type of questions that you will get on the exam. 2021. January 2021. This is it. And it was number 2D and 4A. Let's go. 2D, 4A. Right. Here's another worded variations question. Right? Let's look what I said now. It says the distance needed to stop a car D. That's the first variable right here. D. Alright. D. Varies how? Directly. That means k times the square of the speed s. The square of the speed s. That is s squared. So the d varies directly means equal k times. That's what it means. D equals k times. So we know from the get-go that d is equal to k times the s squared. That's what they said. That's what that statement up there means. Alright? It says a car traveling at a speed of 70. So you know they have to give you information to find the k now. Where is it? A car traveling at a speed of 70. That s equals 70 now. Because a distance of 40 meters to stop means that d equals 40. That information is to find k. This. Assuming that we're using that method of finding k first, that the question can actually be done without finding the k. We're going to continue practicing that way to find the k. And you plug these values in this to find the k. Alright? So let's go. So we're going to use find k first. Find k first method. And it is s equals 70, d equals 40. Plug them in this. So the 40 go in here and the 70 go in there. So we're going to get 40 equals k times 70 squared. So divided by the 70 squared, you get a k equals 40 over 70 squared. Let's work it out with the calculator. Fraction 40 over 70 squared. Let me see what that is as a fraction. I'm going to put this 2 over 4, 2 over 245. So I'm going to write k equals 2 over 245. I'm going to accurate value. So now that we know that, right? Now that we know that, it means that this formula becomes, we plug this in here for the k. So this formula then, which represents the relationship between them, become d equals 2 over 245 times s squared. S squared. 245, right? This 5 better. And what they want? They want to know the distance. That's they want to know a d when the speed is 80. So I'm put 80 for the speed. So we can say when s equals 80, the d that you want becomes 2 over 245 times 80 squared equals. That's what we're working on. Alright, so it becomes 2 over 245 times 80 squared. 52.2. 52.2. Three significant figures. And so what distance? The distance is in meters, see? Meters. So write meters on it. Done. You understand that?
Yes, sir. Yes, sir.
Good. So I think I also give you four something to do. Right, now here's a nice question. So you see, ever so often the question will look a little bit different, but the concept and the principles are the same. Alright, this one says the diagram below. So it's a function, this is the function I gave us. Written another way, it's f of x equals 3 minus 2x. That's your domain, and that's your range. Alright. And this is basically the relationship formula. Alright. It said the diagram below shows the mapping diagram of a function f. Determine the value of a. So a is the value that is mapping from 1, from -1. So you plug the -1 in there to find the a. Alright. So you send this, the a is equal to f of -1. Alright. So let's put it down here. A is equal to f of -1, which becomes equal to, I'll put -1 in this function right there, right? So it becomes 3 minus 2 times -1. That's 3 plus 2. I will set with 5. Now I could know that it's 5 as well now, because that's a linear function, right? And these domain values going up by the same amount, going up by 1. I know that these increase by 2 plus 2, no, decrease by 2, sorry. It says minus 2, minus 2. And this must be minus 2 as well. No, this is minus 2. You add this to the 3, you get 5 up here. So x equals 5 is correct. Alright? So not a, not x, a. So a is equal to 5. The next part says, determine in the simplest form the expression for the inverse function, f to the minus 1. Now, f of x, remember, is 3 minus 2x. I'm going to inverse that, right? Let's do it over here. So f equals 3 minus 2x. Inverse it. This f becomes x equals 3 minus 2 times this x becomes f to the minus 1. So take this r, make it positive first. We're going to get 2f to the minus 1 equals, take this x over here and subtract it. We're going to get 3 minus x. And take this 2 and divide it under here. So this becomes f to the minus 1 equals 3 minus x over 2. That's it. Alright. Then we come to this question now. Remember? So they give us f squared now. Remember, f squared means f of f. Means f of f. So f squared of x is f of x. This means you're putting f back into itself. So it becomes equal to. Let's write down the two f's and just show it clear on the screen. F equals what is it again? 3 minus 2x. 3 minus 2x. And another f equals 3 minus 2x. And we're trying to find this composite. So like I put in one into itself. So taking this one, putting it into here. And see what we get. So this then becomes equal to this 3 minus this 2 times putting this inside here. So now that's what should have been done. 3 minus 2x. Alright, and it says must simplify it, the simplest form. So if we simplify this, let's expand it out first. We're gonna get 3 negative 2 times this 3 is negative 6. Negative 2 times negative 2 is positive 4 times x. Now this 3 minus 6 is negative 3, so this all becomes equal to negative 3 plus 4x. That's it. The last part now says take the value of f to the minus 1. F of f to the minus 1. It's not even working now. Answer for this one is just negative 2. F of f to the minus 1 of negative 2 must be still negative 2. Why is that? Because the function and the inverse, they reverse each other. So it's like you put f to the minus 1 on negative 2 first, and the cat goes somewhere. F is going to bring it back to negative 2. Let me show you. Like a diagram way. So remember now, this means this followed by that, right? So like you have a negative 2. Right? And you put the inverse function on it first. So the inverse takes it to some unknown value. That's what the inverse is. F to the minus 1. What do you think the f gonna do now? Remember, you're gonna apply the f to this result now, you know. So if you apply f to this result now, f is actually the inverse taking it back to the 2. Remember, this means f to the minus 1, f to the minus 1 on negative 2 followed by f, this f out here. So f to the minus 1 takes the negative 2 to some value n, right? And then you're applying the f next. What will the f do? The f will take the n back to the negative 2. That's why the answer for this is negative 2. It's doing no calculation. If you do calculation on this question, you're wasting time. Trust me. So we're doing a composite of f, and it's a f and f to the minus 1, and a value, it must get back the value. Can literally write this. Can literally write this. Can literally write this and know this. F of f to the minus 1 of any number is equal to the same number. Can turn them around as well. F to the minus 1 of f of some number must be equal to that same number. That's what we do here. So negative 2, so it's a negative 2. You do 1 mark for it, and so don't really need to write down the answer here. It's only know the work. 1 mark questions don't really need any work. And so the question says state, meaning that no calculation needed for this. Let's write it down. But understand that?
Yes, sir. Yes, sir.
Good. Alright, let's finish it up. I think this question I asked more on. There's another question I thought that this was. I'd ask some more. I guess we'll book up on that question some other time. Don't worry about it. Was there anything else on this paper I wanted you to do? 2021. This was a 2D. Let's see. That was 4, or finish 2 questions on this. Alright, good, that's a variation one. So that's, we have one last paper now, 2019. I gave it to them. You know, we're gonna call it that day after this. And this is 4A and 8A and 2019. Let's see now, 2019. Right here. Alright, 4A first. Variations question again. Worded. It says quantity P varies inversely as a square of V. That's V squared. That's inversely, and the first variable is V, is P. What does that mean? It says using the letters P, V, and K, write an equation connecting the P and the V. So the first variable P is inverse portion, means K over the square of the second variable V squared. That's what they want. And then, as I said, when it's the inverse variation, I can take and multiply it over here and get PV squared equals K. And find K first as normal. Next part says, give me that V equals 3 when P equals 4. This is to find K. This is for K. Alright, known pair of values. Determine the positive value of V when P equals 1. So we're going to find out what the K is first using this. You don't have to, but we're practicing that we will find the K first. Alright? We don't absolutely have to. So find K first again. Find K first. So we're going to put them in this here and this there. Alright, we put in the V equals 3 and the P equals 4 inside here. So the P is 4 and the V is 3. So it's 3 squared. That's equal to the K. This is 4 times this is 9, that's 36. So the K is 36. Probably can't put it up here now, because I know what it is. So means then back to this, that this thing right now, PV squared equals 36 all the time. And now they want us to find the value of V when the P is 1. So means I want to put the P is 1 in this, and we'll put the V. That's gonna be 6. So when the P equals 1, probably this in here, it means that V squared is 36. I'll put 1 if you want. And then square root both sides. I wrote 66 should be 36. Therefore, the V equals, I'm saying, positive value. So just square root of 36, which is 6. That's it. That's how this question now will finish. But alright.
Yes, sir.
Yes, sir. Yes, sir.
Beautiful. So you can do it, understand it, and get it in your real exam, you can do it again. Alright, you can do it again. Number 8. Number 8 next. Number 7. Alright, last functions question that we're doing today. This question gives us these two functions, f G. Alright, this is what I told you about in the class. Eh? This one don't say undefined, you know. Because it says, state the value of x that cannot be in the domain of f. See, I tell you about that in the class. Here it is. State the value of x that cannot be in the domain. It is the value of x that's going to make the denominator equal 0. You don't want the denominator to be 0. Same as saying the function is undefined. It means that the function becomes undefined for that value of x. Same thing I told you about. Same as saying the function is undefined. So this is basically, that is when f is undefined. Or that will make f undefined. It's when the denominator equals 0. This happens when, I see no calculation needed. That's why it says state, you know. I know you don't need a big calculation. It happens when the denominator becomes 0. And you're solving for this x now. Go over the 1 and divide under the 2. So it will be that x equal minus 1 over 2. This is 1 mark for it. But don't matter how many marks for it. We want the 1 mark. We want every
Yes,
mark.
sir.
Yeah.
Question.
Yeah.
So for in questions like this, would it be same as well when it's undefined, or that's completely different?
It's the same thing. The
Oh,
function
okay.
becomes undefined when the denominator is 0.
Yes, sir.
And the value of x that's going to cause the denominator to be 0 cannot be in the domain. Because a value of x that will make the function undefined cannot be in the domain. Because look at it. If you put half in this function, right? Look, let's try work out. F of minus a half will become 9 over 0. 9 over 0 don't have no value. Can't work out no value for 9 over 0. That's an undefined value. They call it infinitely large value. It means that when you have your mapping diagram for your domain and your range that you're supposed to have for your function, if you have minus a half in there, it's not going to be mapping onto anything over here, whatever the values are over here in your range. The minus a half will not be mapping at all. It's going to be free because there is no value for it to map onto. And remember, if you have a free value in a domain that is not mapping, then this relation is not a function. So this cannot be a function if negative a half is in the domain. Because negative a half causes this formula, that 9 over 2x plus 1, to be undefined. It doesn't carry on to any value. Negative 2 does not map onto any value. Now, negative a half, sorry, does not map onto any value on this function. And so if it is in the domain, it will not have any value to map onto. And if there's a value in the domain that is not mapping, then that mapping diagram or that relation is not one for a function. That's why it says cannot be in the domain of f if f is a function. It means that it would not be a function anymore if negative half was in the domain. You understand what I'm saying? Aiden, you understand what I'm saying?
Oh, yes, sir.
Good. Right? So just another way of saying what value of x will make the function undefined. So the working out is the same. Whether I say undefined or not. And I've been making that connection in the class. Several times I said it in the class. That they don't have to use the word undefined in the question. So this is basically asking you the same thing. If the question is say, find the value of x for which f of x is undefined, this will be the answer same way if they had said this. That's why I wrote it there on the screen. It's the same thing that is happening here. The function becomes undefined when the x equals minus a half, which is still to say that minus a half cannot be in the domain of this function because it then will not be a function. Because it will not have a value that it is mapping onto. We did say from the very first class that for a mapping or for a relation to be a function, each element in the domain must have a value that is mapping onto in the range, and it can only have one value mapping onto in the range. In this case, the negative half would not have a value to map onto, because 9 over 0 is not a real value, not a value that we know. It's not a defined value, it's undefined. And that is the premise on it. Alright, enough of that. Next part says we must find g of f. No, f of g, sorry. Remember, this means g into f, right? G into f. That's what it means. What is the g and the f? Let's write them here so we can set it up. So the f is which one? 9 over 2x plus 1. And the g is x minus 3. So this f of g means g into f. It means that this all of g is coming to f right here. That's how we construct it. Alright, and so f of g of x becomes equal to 9, that's this 9, over 2 times at x minus 3, and you add back this 1 under here. And then simplify it, simplify it. So it's 9 over 2 times x, that's 2x. 2 times minus 3 is negative 6. Negative 6 plus 1 is negative 5. That is it. Anything else on this question? Yes, they want f to the minus 1, the inverse. That's all I want now. So remember now, we're doing the same process. F equals 9 over, what is it again? Let's make sure. 2x plus 1, right? 2x plus 1. 9 over 2x plus 1. Let's inverse this one and show you. 2x plus 1. And we're using the same method. Same method, we're not changing the method. It will work. Just the ability to transpose. Inverse this. So this which represents range on the function becomes the main on inverse x equals 9 over this x becomes the range on inverse, which is f to the minus 1. So you get 2f to the minus 1 plus 1. And you're trying to make this a subject. This one kind of easy, because this is only f to the minus 1 in there. Right? You know, like the case where you have another one on top there. So easy way to do this is take the r of this diameter, multiply it up here, and let's take this x and divide it under here same time. That's one way we can do it. Right? So we would get, if we do that change, we would get 2f to the minus 1 plus 1 equals 9 over the x. Then after you have that, now you're transposing everything away from this f to the minus 1. So we can take this one, carry it over there so first, and get 2f to the minus 1 equals 9 over x minus 1. And then to get rid of this 2, we can take the 2 and divide it under the whole thing. Or we can say divide each thing by 2, divide this by 2, divide this by 2, divide that by 2. Or another way we can look at it is to say to get rid of this 2, we can multiply 2 by half, which I think is a more friendly thing to do. Multiply everything by half. Right? Multiply everything by a half. So you multiply it by a half, this 2 gone, get f to the minus 1 alone equal, multiply this by a half, it become 9 over 2x. Multiply this 1 by a half, it becomes minus half. That's the answer right there. And that's the f to the minus 1 of x is putting back off x on it now. But I did that.
Yes, sir.
Let me
Yes,
show
yes,
you.
sir.
Let's do it another way. We don't do it. Let's do it another way. I'm not sure you. So I did times half right here to go from this to that. Alright, let's do it another way over here. That's from this step, right? Let's do this step from another way over here in purple. So starting back from right here, we have x equals to the minus 1 plus 1. Let's say you multiply this across here, multiply each term by the x. So it's x times this first. We will get 2x f to the minus 1. And x times this will be plus x equals 9. Then I'm transposing everything to make this a subject. Care over this first. I will get 2x f to the minus 1 equals 9 minus x. And this 2x is divided under here. And so we'll get f to the minus 1 equals 9 minus x all over 2x. That done. You might say, oh, this and this look different. So they're actually the same. Right? Because if I take this half, like you want the two of them have the same denominator, right? So if I take that half over here, I multiply the denominator by x to get it to be the same as that. Then I also multiply the numerator by x. Then what you will end up having is 9. Then it should become minus x, minus 1x, which is minus x over common denominator of 2x. And it's the same as that. Alright. But if you got this by itself and left it, you have to give a mark. It's still correct. Okay, that is it for today, guys. I think we're done for today. So we did an hour and a half, just about an hour and a half, which is good for a Saturday. Quick revision.
Very nice. Yes.
Alright. Very good.
Yes, sir.
Alright, beautiful.
Mhm.
Beautiful, beautiful, beautiful. Alright, guys. So I see you in class tomorrow and Monday. And we will start our new topic tomorrow and Monday. Alright? We're gonna start coordinate geometry. It's a 1 week topic actually. And then next week we're going on to a nice topic of linear programming and inequalities. Alright, see you then. See you in class tomorrow, guys. Bye.
Later.
Bye everybody. Tomorrow in class on Monday.